When people hear the phrase energy efficiency, they often think it sounds technical, expensive, or complicated. But the truth is, the core idea is incredibly simple. Energy efficiency is really just about one question: how much useful result do you get for the energy you put in? That's it. At its most basic level, the math looks like this: efficiency, useful output, total input. And if you want it as a percentage, you just multiply by 100. So let's say a machine uses 100 units of energy, but only 80 of those units actually become useful work. The other 20 are lost, maybe as heat, friction, sound, or vibration. That machine is operating at 80% efficiency. This is the simple math behind energy efficiency. The more of the input energy you successfully turn into something useful, the more efficient the system is. Now here's where it gets interesting. Almost nothing in the real world is 100% efficient. A light bulb is a great example. Traditional incandescent bulbs waste a huge part of their energy as heat. The goal is light, but much of the electricity turns into warmth instead. LED bulbs, on the other hand, convert a much larger portion of that energy into actual light. That's why they use less electricity to produce the same brightness. The exact same logic applies to cars, refrigerators, air conditioners, computers, elevators, and even buildings. Take a car. The fuel contains chemical energy, but only part of that energy actually moves the vehicle forward. A lot of it is lost through engine heat, exhaust gases, and internal friction. That's why engineers are constantly trying to improve efficiency. Not necessarily to create more energy, but to waste less of it. And that is the key idea. Energy efficiency is often less about producing more and more about losing less. Let's make it even more practical. Imagine two appliances that do the same job. One uses 1000 watts, the other uses 700 watts. If both give you the same result, cooling the same room, washing the same clothes, or lighting the same space, then the second one is more efficient because it delivers the same useful output with less energy input. That's why efficiency matters economically too. Lower energy use means lower bills. And on a larger scale, it also means less strain on power grids, less fuel consumption, and often fewer emissions. There's another simple way to think about it. Efficiency improves when output stays the same and input goes down, or when output goes up without increasing input too much. That's the math companies and engineers love. Because if you reduce wasted energy across millions of homes, vehicles, and machines, the impact becomes massive. Even insulation in a house is part of this same idea. If your heating system works hard, but the heat escapes through bad windows or thin walls, then energy is being wasted. Better insulation means more of the energy stays useful inside the house. Again, same principle. Useful output divided by total input. So, in the end, energy efficiency is not some mysterious engineering buzzword. It's just a measure of waste versus usefulness. The simple formula is efficiency, useful output, energy input, and the closer that number gets to 1 or 100%, the better the system is at doing its job without wasting energy. So next time you hear that something is more energy efficient, it really means one thing: it gets more done with less waste. And honestly, that's one of the smartest ideas in all of engineering.